ThoughtWorks, which is one of our sponsors making this all possible. Welcome to Kisitu.
Hello, everyone. Can you hear me?
Yes.
Cool. So we're here to talk about Python metaclasses. Basically, what you should expect out of this talk is a basic introduction to what Python metaclasses are, what you can do with them, and probably why you might need them. So we're going to go through some basics before we talk about metaclasses, and these basics will be a building block for what we want to talk about. So the first thing is everything in Python is an object. Basically, your functions are objects. Your modules are objects. Your classes are also objects, which is something very funny. I don't know whether we can try something out here. Excuse me. Yep. Just something small to show. I can import sys, and I can say sys.name. It already has a name called sys. So it's an object. It has properties. I want to go back to my presentation. Sweet. Yep. So we use classes to create instances of objects. And I have a basic example of a class called foo that takes a bar. And down there, I have an instance of foo, which takes in a bar called Alex bar. So we have this thing called type in Python, which basically tells us the type of things. So you call type, you pass it something, and it tells you what type that thing is. Do that make sense? Let me just play with it a bit. So I call type. Sorry. Type on 1, it tells me type 1 is an int. I call type on sys, it tells me sys is a module. Let's talk about how do we create new types in Python. And basically, that's how we would create types. We would have to write a class that that describes whatever type that we want to create. This is how we would do it in Python 3, and this is Python 2 syntax. Basically, Python 2 classes have to explicitly inherit from object. Interestingly, still type can help us to create new types. Okay, so if you did this kind of thing, you would be creating a class called foo. Okay, so let's just play a bit with that and see it in action. So I say foo. So basically, if I call help on foo, we find that we have a class called foo. And it's basically an empty class. It has nothing, right? So I can instantiate foo. Okay. I do have, it's just an object of foo. So this is another way of creating new types in Python. Oh, sorry. I'm going to have to keep switching. Sorry about that. So that's another way of creating new types in Python. We'll look at that again. Sorry. So type, basically the signature of type, it basically looks something like this. You have, you call type, you pass it something here. You can give it a name, right? And then you give it a bunch of option arguments and then keyword arguments, right? So the way you call type determines what it does for you. If you call type and you just give it an object, it will tell you the type of that object. However, if you call type, like we just did previously, it will return a new type for you, all right? So what is this type thing, right? What is it, you know? It looks to me like, it used to look to me like a function until I did some more research and found out that type is a meta class. So by default, this is how your Python classes get created. This is the thing that creates your classes in the background. So every time you write a class, this type thing is called on your class, and it's the one that actually creates your class. Because when we were starting, we said that everything is an object, right? So we use classes to create instances of objects. Then what do we use to create classes if they are objects too? Type is the answer. So type is a meta class, and it's the default meta class that creates your classes in Python. Okay? So that's what meta classes are. They are a special kind of class that creates classes. Every time I hear this word meta, it kind of like, you know, it just brings, you know, when we hear metadata, it's basically data about data. We hear metaprogramming is basically, you know, writing programs that manipulate programs. So I guess it would be right to say meta classes are classes of classes, right? Something like that. So that's what basically they are, or that's what at least I think they are. They are classes that help you to create your classes. Because when I talk about creating your classes, at this point, classes are also instances. Because the first basic that we talked about was everything in Python is an object. So that means even your classes at runtime, they are also objects. So how they are created is through meta classes. And okay, we'll see this later on. So let's go back to type a bit. The signature of type, again, we are revisiting it. When you're calling type, you're passing it a name, right? The first argument that you pass to type is a name. The second argument that we all saw, if I can backtrack a bit, the second argument that we saw is this thing here, an empty tuple, which is basically a list of all your base classes, all the classes that whatever class you're trying to create inherits from. Yes. So bases is just a tuple of all your base classes. And then there's something called the class dict, which is basically a dictionary of all the attributes of your class. Basically a mapping between their names and their values. All right? That's type. So if we continue, when you have a class like this, a class called foo, at runtime, that class is an instance of the type meta class. Let's just do that. Let's see. So I'm going to call type on foo. And we find that the type of foo is type. Or if we did something like foo.__class, you find that the class that created foo is type, right? So come on. So how do we define meta classes? This is how we define meta classes. Sorry. It's quite big. But generally, when you're creating a meta class, the first thing to note is it inherits from type, right? It doesn't inherit from object. It inherits from type. Then you have three methods onto that class that you can override. One of them is the __init, and the __new, and another one called __call. You notice here that we are not taking in self, right? But we are taking in the class. Because at this point, the class is just being created, right? We don't have self, because basically self helps you to, it basically helps you to attach attributes to the instance. But here, normally, the class is just being created. So we have the class itself, the name of the class, and its bases and the dictionary. I'm going to talk about what's the difference between those methods. Yeah, there's a reason why call is red. Let's try to move on and see. So we saw __new and __init. The difference between them is because new is called, it's the thing that actually creates your classes. or it's the thing that actually creates objects in Python, right? Underscore underscore init is just the thing that does the initialization. So there's a difference there. New is the thing that creates your class. So if you want to intercept your class creation process and do some stuff, then you should be overriding new. But if you want to intercept the initialization of the class, initialization, I mean attributes being added to the class and their values being defined, you should be overriding init. Okay, so there's always, you need to know what you want to do when you're creating a meta class, and you override one of them. You don't have to override all of them. You just have to override one of them. And you always should remember to call super. So just to go back a bit, underscore underscore call does not get involved in the class creation process. It gets called when you're creating instances of your new class, right? So that's why I marked it in red, because it gets called later on, at a later stage, when you want to create instances of your new class. So if we went to here, if I was doing something like this, this is the point at which underscore underscore call will be called. So if you want to put some code there to, let's say, validate what kind of arguments are being passed into your class, you could override underscore underscore call. Let's go. Next. So having created our meta class, this is how we plug the meta class onto whatever class we want it to work on. This is the Python 2 syntax, anything Python 2. This is how you would do it. You have a static variable in your class called underscore underscore meta, and then you put the name of the meta class. In Python 3, the syntax changes a bit. You basically have a keyword argument called meta class. So I want to attempt to write some code here to see just one example of how a meta class works. And if time allows, we could try the second example. So the first example that I would like to do is making final classes in Python. Correct me if I'm wrong, but I think the concept of final classes is not available in Python. But mostly, I think, so let's try to play with something here that I noticed. So the bool class of Python, the bool class, we cannot inherit it. So if I created like a class called f, which is inheriting from bool, I'm going to get some sort of error. And it says bool is not an acceptable base type, because basically you always want a boolean to be true or false. You don't want anyone going in and playing with it and trying to change it. So, but generally, like with normal Python syntax, at least I have never found a way of making a class final, right? So I'm just going to try to write a meta class that would help us to achieve that. So I want to create a class called final. And this class is inheriting from type. And I'm going to override only one method, the new method. So the thing we want to do here is we want to iterate over the bases. And we want to define, we want to find out if one of the base classes is an instance of the final class, and that means we should not be allowing someone to inherit from this class. Because we said that at runtime, a class will always be an instance of its meta class, right? So if one of the base classes is an instance of final, then we should basically not be allowing them to override it. So then we want to raise a type error. We want to say, boom, can't inherit from just happened? Hope there's no error there. Then we want to call the super. So if I create a class called foo, and I plug that meta class on that class, on foo, at this point, it should not be allowing me to inherit from foo. Oh, sorry. This is bar trying to inherit from foo. Yep. What? Sorry. Yeah, there was an error in my code. Not. Well, let me look at the error. I don't know why I can't see that. What? What? Excuse me. I can't actually see the end of the line, so it's a bit tricky. What? Command?
I think there's a full stop missing,
Underscore final. Where exactly?
Just press enter and backspace the line in when you're done editing it.
Okay, cool. Thanks. Let me try that. Yeah. Underscore name underscore. Thanks. Okay. Whoa, cool. So we got our exception and saying we can't inherit from foo. So yeah, that's one way you could want to use a meta class. Okay, so that's the first example that we've seen. Let me try to do example 2. I hope it works. And this time we're going to be trying to decorate class methods using a meta class. Yep. So we have a we have a very ugly decorator method here called log. And all this method does is it takes a function and then it prints calling function, then the function name, and then it returns whatever function it took. So the thing is that, let's see. Okay, I'm going to try to create a new notebook here. Yep. Okay. So, yep. Takes in a function, defines another function here, which takes in basically optional arguments. And just prints something like calling. So you can see when I say function.name, it's the same, like we said in the beginning that everything is an object, so even the functions are objects. So already your function has an attribute called name, right? So at this point, we want to return the function with these guys. Then we return our wrapper function. Okay, let's test it and see if it works. So if I decorate a function called hello, I'm just printing something like PyConZA. When I call hello, yep, our decorator works. So the thing is that, let's try to go back a bit. So we have this decorator. So if I have a class that's going to have a number of methods, and I want to decorate all the methods of that class with this decorator, you're going to find that, let's say my class is called foo. Foo must hate me by the end of this presentation. So if I have a method called hello, I will have to say at log. Then I pass, right? Then I have another method called bar. Then I have to say at log again. So the thing is, the moment you have to write 3 methods, the moment you have to write at log 3 times, it begins to get annoying, right? You don't really want to be repeating this same line of code all the time, especially if you're working with a framework, for example, and you don't really know even what at log means, because here we have defined at log, but just assume somewhere in the framework documentation they're saying every method on your class has to have the at log decorator, right? You don't really know what this thing does, but you have to always keep remembering to put it on top of your methods. I think that's another place we could try to write our meta class and see. So the goal of the meta class will be to basically decorate all the methods of our class. And so we don't have to keep writing at log again. So let's try again. We're going to create a class called logger, inheriting from type, and we are going to override new. Come on. All right. So the first thing we want to do here is to call super. So you always want to call super in your meta classes because, like we said, type takes care of creating your classes, right? So the moment you don't call super on any of these methods means you could be leaving out stuff that maybe type does, which you don't really know about. So you always want to remember to call super. Then we shall say, so we want to iterate over basically the keys, the attributes and their values of the class to determine which one is callable and which one is not. Generally, var's class will return to you some sort of dictionary which has the attributes of the class with their values. So we want to determine if any of the values is callable, and then we wrap it with our decorator, right? So we want to say set attribute on class key and value, right? And at this point, we want to return our class. So all we're trying to do in the for loop is we're trying to iterate over all the values of our class, and all the keys. Yes.
So you called it item, there's a key there.
Oh, sorry. Thank you. That's why it's good to have more eyes on the code. Thanks. All right. So our meta class is done, and let's hope it works. So we're going to create a class called foo again. And foo, we will plug our meta class on foo. Sorry. The meta class is called logger. So I define hello let's just check, see if things work. Right? So if I call f.hello, well, didn't work. What? I forgot. Oh, yeah, thank you. God. I forgot to wrap it, yeah. Here I'd be wrapping it with the wrapper. I mean the decorator. So, yeah, when we call hello, our decorator is still there. And if we keep adding more methods here, we add bar. When we come and call bar, yep, still works. So they can basically help you to attain the dry principle of not repeating yourself. I think that's one of the use cases that you could use meta classes for. You could basically get all the ugly code away and plug it into some meta class, and then, you know, it works for you. So that said, let's go through some advanced basics. I call them advanced basics because they are meta class basics, of which meta classes are advanced classes. So yeah. So a class is an instance of its meta class at runtime, right? I think we did that. Let's do that again and see. Foo, if I call type on foo, it's an instance of logger, okay? Or there's this other thing called, you can call foo __ class, and it tells you. So you're calling the class of the class, trying to find out the class of the class. So meta classes go down the inheritance chain. That means that if I'm inheriting from a class, okay, and that class has a meta class onto it, in the child class, the child class will also be using the meta class of its super, right? And this is a very interesting one. Things can get quite ugly when you're doing multiple inheritance, and if all your base classes are basically having different meta classes. Oh, thank you. If your base classes are having different meta classes, you might get into problems. I think essentially a meta class should basically be a subclass of all meta classes of its base. God, let me repeat this again. So if you have a class and it has a list of bases, right? The meta class of this class should be a subclass of all the meta classes of its base classes. I hope I got this right this time. The other thing is you notice that you will be dealing with class creation, right? So you're going another level deeper. So you really need to know, do you actually need to use a meta class before you try to implement it as a solution to your whatever problem you're trying to solve. And if you read around, they've said that there are almost always other possible solutions. So it should be like you always need to be sure whether you want to be using a meta class or not. I don't know whether we have any questions, but yeah.
Thank you very much. Right, questions one over here.
So I take it that you could use overriding this kind of sort of core to implement some kind of evil dependency injection system as well, couldn't you?
Exactly, right? You can do that, right? Because, well, let's see. Did I get your question right? You're saying you can override.
This kind of sort of core of a meta class.
Yeah.
To implement basically a dependency injection system.
Yeah, exactly. You can do that.
Assuming that there is no magic, but is there a kind of magic that if we were to define this, does new get called again if you patch in another method onto something, or if you added another method that wouldn't automatically be decorated with log?
So if let's say you have this class already created, and you add another method onto it, it will not get called again. So new gets called during the time when the class is being created. It doesn't get called again. So log would not work at that point.
Are there any more
I
questions?
think there's a question there.
So if new is not created, is it possible to pickle the instances that you create of the meta classes?
Can I get your question again?
Is it possible to pickle the instances since you say new is not called?
Is it possible to pickle?
So if you have a meta class, can you pickle and unpickle its objects safely?
I think I don't understand what the word pickle means. Sorry. Does anyone want to help me?
Well, if you have an object whose class has this logger meta class, and you pickle the object, and when you unpickle it, all those methods still
Picking is a serialization.
when deserializing
Ah.
the class, will this method still be wrapped with that log decorated?
I really don't know. I haven't tried that out. So.
Okay, thank you very much. We've got a few minutes if you want to change rooms to go to the other talk, which I have no idea what is in the other room. But thank you very much to Kasitu Augustine.
Do you know Zope?
No?
Do you know Zope? Have you ever worked with Zope?
No.
Zope is probably the first application server written in Python. The example that you gave with the logger.
Okay.